Welcome everybody on a Techfellows Meetup number 3. Those that you maybe enjoyed the previous parts of the Techfellows know that Techfellows is about the community, about people, usually tech people who are meeting and they are talking about tech stuff. So today we are here in beautiful offices of Cisco, and Techfellows is brought to you by Surgelox, Labyrinth Labs, and Slido, and people behind these companies. Today's topic is time to rewrite or refactor, and we have two amazing speakers that will talk about their experience. So I'm your host today. My name is Ivan. I'm Growth and Partnership Manager in Labyrinth Labs, and I'm a non-tech fella. That means that I'm here because my colleagues gave me the chance to be part of this event. And Labyrinth Labs is very deep tech company, but they are thinking about non-tech people, and they are trying to include us in everything what they are doing. They even do non-tech team buildings for us, which is amazing. I feel very good. So this is a short introduction about me. And of course, most of you know Slido, so you can use the hashtag or just go to slido.com and hashtag Techfellows. So we have the first poll. Some of you already chose the answer. And the question is, have you been faced with a rewrite or refactor riddle before? Please take your time. Okay, so most of you went through rewrite. Very nice. Okay, so now you know what you should talk about, Jacek. Okay, thank you very much. This was a very, very short quiz. So now I will introduce the first speaker, Magical Jacek, as I call him. He's a former senior, is it a former, right? Former. Oh, okay, because you don't have it there, but I know it. Former senior director of Sumologic. He was in San Francisco. He lived there. He joined some crazy world of startups. So he maybe talk about it in the networking session. He worked in Sumologic from the beginning, and he stayed there until the IPO and maybe a few months longer. And it is very interesting because it was privately taken for $1.7 billion. So he has a lot of experience. So now you say the stage is yours, please.
Yeah, thank you. So I'm actually. Thank you, Ivan, for introduction. And actually, the story when I moved back from California was like, oh no, I could not work 9 time zones away and just be engineer. I have to reinvent myself, and that's how I went to dark side of managerial life, which is like a little bit less area of comfort, but I found it intriguing, and it's like so many great engineers. Why don't we just hire them and build something great? So that was part of my story, and then. So then what we learned when you like work in a startup, that you do a lot of things quickly because you need to gain market. You have like some big enterprise clients that want this thing for yesterday, but eventually every once in a while you hit the wall, right? And what do you mean by hit the wall? That usually means that let's say like you try to add another feature and it takes ages, or the quality is not there. Product is buggy, outdated, doesn't scale. Or it's like, it's everything works, but there always needs to be 2 engineers that doing some magic maintenance work. Or it's like, as some companies go, or they have their homegrown tech, and yes, if you spend years working there, maybe you could find your way out. Or it's just like moral thing, like you have some technology, but people just run away, they just resign from their job, and they list it like as a reason, oh, I wish I could work in this new shiny setup, not in your old crappy stuff, right? And it's usually a combination of those two. But sometimes, like, you hit the wall, it means that it's not like a little problem that somebody could do it over a few days, but it's like a big technical problem that you don't address. And then you decide, okay, let's do something about it. and usually the first thing what comes to your mind, let's rewrite it all. And it's challenging because, it's like first business usually doesn't understand why you will not do anything, but you just rewrite. And what worse, there is a lot of industry opinion that if you do that, it will be really, really bad, right? And even like one of the most famous bloggers, like Joel Spolsky, wrote like a whole article, like things you should never do. It was even like part 1, and he on purpose never did the part 2. That, and he lists like a whole list of companies that, pretty much died because technical people decided to rewrite. They underestimated their effort. It went for so long. And the classical example is Netscape. For those of you which remember, that was the first graphical web browser. And it was like internet wars. Like Microsoft was trying to get some share. It created Internet Explorer, which was like really crappy. Everybody hated Internet Explorer, but it was for free in operating system. That was one of their playbook. But it was like improving. And Netscape decided that, we rewrite everything. And for almost like 3 to 4 years, they did not ship anything. And that turned out to be fatal. But, it pretty much killed their whole business. So a lot of people say, like, if technical people want to rewrite, they're just complaining, you should just not listen to them. That's like one school of thought. But especially, and the bigger it is, it's more painful. But on the other hand, maybe these dragons are not that bad. Maybe like a little lovely dragon that actually, like, is not as bad. The bad is not doing that. And I was trying to research what are the worst examples of people that should rewrite something, or I did not do that. MySpace was one quick example that, at some point it got all of the users. It was the most popular social network in USA. And usually social networks should be sticky because everybody's there. But it was like so technological problem. Website was loading for 40 seconds. It got hard time expanding, and eventually it killed it. And even the worst example is that, is like Nokia, right? For some reasons, like, I don't know, anybody got Nokia smartphone here? But, maybe you remember, it was that Nokia know really well how to do hardware. They were really great at it. But, the software was like, not really managed properly. So at some point, it was like so much debt. They tried Symbian, they tried to rewrite with Mibo. But at some point, it was like, it was just terrible. It was like, if you want to read, there's like a whole book about it. And people have like separate brand for each hardware device. Just imagine, you have like one operating fix, how you distribute it. Or the build time was even like 2 days. Make some fix, and then the whole team has to wait for one build just to see if it's working. Right? And they've called chairman, so how the person which represents the most shareholders, when he was hearing about this and he was like software guy, it was like, Nokia is like completely screwed up, we need to rewrite. And he attributed that they did it too late to like a failure of Nokia smartphone business, right? So if somebody says that, the company had got like $1 billion customer that was like a Tron, and it died because, it did not know how to rebuild to an era when it's like all touch screen, and then every user, you need to have a lot of apps, you need to have very complex software, and you don't know how to do it, then it's like a problem. And he, like in his like reflection after many years, was, you should do rewrite. So what that means for us? I would try to make it short and try to distill the management lessons, because always there's a lot of arguments technically, you should write in C, you should write in Rust, but that's like one part. But the big picture for managers or like directors or even leaders is that, rewrite is not something that you should take lightly. It's like, that guy will do it, don't worry about it. No, it's like very strategic thing that would make or break your company. And the bigger your company is, the more user it has, more customers, it's even more important. And it's like a complex, because, there's like many people. There's like people from business that may not appreciate the challenge. There are people like engineers which may like, leaving the company. They are leaving the company because things are like too complex. It's much easier to start from scratch. There are many opinions. It's usually not like a war that you could just make orders. No, you have to convince everybody to do that. There's like many dependencies, and usually it's like in quite many cases, it's like surprisingly either takes longer or there are many things that you uncover during the migration. So if we distill the managerial lessons, and if we think that this is like a thing worth learning, no, there is like a problem. Okay, have anybody got like a course on university how to manage rewrites? Not many. And likely you're also not going to, even though the slide show quite a few done that, likely you are not going to do that many of them, especially the big ones which take many people that are complete. So how can we learn for this? Usually it's kind of like, I find like, if people like role-playing games or like kind of like business simulation or like military war game, you do this like scenario planning. Okay, what if we rewrite? What if we refactor? What if this took longer? What if, we do rewrite and then the most important customer came to us and asked for this little feature, right? And how do we do it? And then we could like simulate what kind of outcomes we wish for or how we would manage like engineers. And this is like what I find really intriguing, that doing this kind of like exercise is kind of like really useful for managers or even like technical leaders. So later when the situation arises and there's like a lot of emotion, there is a lot of like time pressure, at least you know and try to behave as rationally as possible. It's very hard to reflect and learn skills while sometimes you are in the middle of doing something that's like very challenging. So I would like point you to 3 examples from my life career. I'm happy to take any of your questions. So we actually have some time for the question if you're interested in details about scenarios when we hit the wall. We feel that, one of them it was web scale DB. And I will ask you later in next slide, what should we do? So feel free to ask questions. This scenario was that, at some point in time, people get sick of SQL database, decide that this is like not the way how we go. There's like even famous like, video, web scale DB. Anybody know? It's like MongoDB parody. But we went with something like that. And we use like a central NoSQL database for all of the users, for all of the accounts. And there was like a lot of rationale. One of them was like permission system, which was like really nice. We really were proud of all. It's like really hard to permission everything in SQL, while now it's easy. But eventually it turned out that this DB was not really major. It was not like, it could not run more than one server. It was like crashing, several outages. And it was like, everybody was afraid to add the data, but think of that, you have like companies, any feature will often require some data and everybody is like afraid to use it. So it slowed down us a lot. Right? So there was like some people arguing, okay, we should refactor. Some people arguing, oh, we should rewrite. If you have any questions, I'm happy to answer. But other than that, like, feel free to vote. What's your vote? Like, how we should deal with this spider. Should we burn the spider or, should we feed the spider? And vote. 4 votes. 6 people vote. 9. Also, I'm happy to take questions, so you could change your mind. Let's see. Oh, very interesting. Half by half. So that was how we feel for some time, because there was like, actually in many companies, it was like, oh, we should like, there was like one fraction which was, oh, this is like the best database. If we just tweak these few things, it will be all nice. Like, why destroy it? Because some people like it. And also like some people say, no, we should like just burn it. And it turned out that the right, okay, there's a question. Should make the decision. So in my opinion, it's sometimes like collective decision. It's kind of like, it depends on the company. At the end of the day, it was, I believe in many companies, like sometimes even goes to CTO, because especially in this case, it was like, oh, there was like vocal opinions, there was like a few people, and eventually CTO decided one way or the other, because there was like, a lot of people. But to be people, at the end of the day, in some companies, it was kind of like a voting system that both managerials and technical leaders were like voting on what's the right solution. And in this case, it was like CTO has to tell it, because it was like half by half. And a lot of those people got like a very good arguments. Oh, I think, sorry, that's like previous. So the story, how it evolved, like people tried to do refactors because that was easier to sell. Like, oh, why those rewrite fancy people, like, let's do refactor. And it turned out that, it was not easy, it was like, still even though we pay something, why did you put on own NoSQL database? Because we're scared of SQL, because the founders were burned from using a previous company SQL database. So we didn't like migration, things that. So, yeah, and yeah, no, but we did not put our own NoSQL database. We used existing ones, but it was not popular one. It was one that appears to be popular, but not the popular one. It lost. Yes. Okay. Pay attention. So the rewrite being dead end because still it prove out, okay, you have like single server. Anytime you take down, the whole service is down, like, which is, and for us it was really important. And what was worse, we were hitting some unknown bugs. So things crashed and nobody knows why. And even those engineers for the company which wrote those databases didn't know that either. So what we decided, okay, that's like, no, like that's dead end. And we decided, okay, we no longer use this database, but instead of replacing it with one big rewrite, you could not put any new data to this database, like a new type, and you have to migrate out. So eventually we end up, this was already a company of, just for the sake of that, like around like 50 engineers, like when it happened, like 52. So there was already like several teams, and each of these teams, like of 5 or 10, has created their own database for different needs. And this primary, surprisingly, SQL. Almost everybody picks SQL, other than a few people which actually got valid use case to use something like DynamoDB. But the challenge with those migration was that, we fixed this issue quickly in terms of like the most of data was moved away, but the long tail of data of those things that are not changing or things like that, that took even like, I think, 2 to 3 years. Any questions? The second scenario. Second scenario was like, when we started, like when Sumo started, it was like, oh, there was no really like good big data framework systems. How can you execute queries, things like that. So what we do, we wrote our own, right? And it was like foundation of the main product, of main flagship. And it was quite unique in many ways. I could like deliberate on the technical, that things that we believe nobody had at the time. And we were really proud of that. But it turned out that, we end up in some mess. That you go to all of those websites, you look at Spark, you look at that. A lot of them look like so nice, so easy to implement, while our own stuff is so complex, things like that. So we thought like, we got so many limitations, or people need to spend time learning. Why not just rewrite, right? And okay, I just duplicated somehow. So what do you think? Any questions or anything? I don't think I should really see, but feel free to vote. I could take questions in person too. What should we do? Rewrite, refactor, or just engineers are grumbling and it's like, and we can see it's telling. Yeah. So surprisingly, that's like the same consensus that we have at that time. In this case, actually, most people will say, yes, we have to refactor. It would be so much nicer to use these new frameworks. It's opposite. People in Sumo say like they should rewrite it, but you all think like we should refactor. So you are right, we were wrong. Okay? Sorry. So the story was that, the good news only was that because of these scenarios, people were worried, some of the refactors was like, let's not wait until we implement everything and migrate. We were running in cloud. Let's just divert some traffic, like shadow traffic, and run in parallel. Okay, if that would work, right? And surprisingly, it proved out, and we proved what are the most important performance characteristics. And it proved out that even though the new system seems to be much nicer in terms of code, it didn't work well. if we have like 9 most important like searches, like 6 of them were significantly slower. So, okay, we try to write new system, and at the beginning we are hoping it to be 2 times or much better, and most of the situations are much slower. And we have to optimize so much to a point that we reach limit of those frameworks that we have to almost like break them to make some very weird optimization, which is kind of like undoing why we would like to use some nice library if you have to fork it. And it was like, dead end. People fall because what we learn in our system, we make like a lot of clever tricks, hacks, how to optimize stuff, because our use case is like very, I would say, not typical. Okay, I will answer. So, exorcism. I don't know. It's like kind of like the exorcism. I would say definitely sometimes code style. Like exorcism is like if code is like just so messy, people use all of the different styles. It's like definitely exorcism. If at least some principles are followed, usually you may try. But and in this particular case, we learned that it's like actually it's like a unique source that we could make like a query. We could see partial results very frequently, and actually we kind of like start appreciating our system more. So we backported those. I think there were like 1 or 2 very clever tricks that we learned from this open source, how to do joins in distributed system that we just backported to system, but we kept our own system and iterating. And how do you estimate time effort? I'm sometimes like not the best in terms of like, estimating time upfront is sometimes hard. You could make exercise, but usually I would argue once you have like a 1 month project, once you have like a few months or like 1 sprint, you kind of know. This is like intuition, but if you got some initial estimate and after working that for 2 weeks, your estimate is getting bigger, you could like estimate, okay, you're vastly underestimating. So I kind of like believe it's very, very hard to estimate upfront completely. It's like almost impossible, especially big projects. Like if something takes more than 2 weeks, likely not estimate, but it's very easy to track what is your current estimate, right? And after every week of working project, instead of your estimate shrinking how much time it takes to completion, you just take it will take longer. Likely there will be way, way more unknowns, right? But if your estimate is like, okay, we will do that in 3 months, and it's also like some magic how you came up to 3 months. But after working on 1 month, you take it, I will be done in 2 months, and likely your estimate is accurate. So I believe this is like hard part that people are. It's much easier to course correct than predict. Okay. Maybe. Okay, I will take 1 more question, then we'll move the other. So convince both that you need to spend 6 months. I would say that was these 5 arguments that if you don't see like compelling reason that let's say you are shipping too slow or like you are like having like some quality issues or it's very hard to onboard, like you could not hire a new person and make them productive in like a month or 3 months. That's that was the or you need to spend someone like instead of like running autoscale system, someone to babysit it. That's like a very good argument for refactor. Other than that, that's like hard thing. And usually in our case, it was collective that many people saw this need. It was not like if there is like just one person wants to do rewrite, it's usually good to understand why this person got like so much different opinion than everybody else. I will have to, I think I'm like short on time, so I will have to. So the last case would be, okay, let's say you are Bratislava and previously when there was like kings here, things like that, you want to send a message, you send it by horse and it takes some days to read the message. So same things about the build time and cities. Like I believe that this kind of like measure for many companies of how good they are, especially if they're running on cloud or like on as a software as a service, how painful it is to develop like a new feature and ship it to production. And there's like different pieces of how long it takes to build, how long it to take a test, how long it takes to deploy to production. And in our case, initially when we were small, it was super small, but eventually there were not that many tools. It was all slowed down. And eventually it was like painful. So we decided why not just use open source and make it like really, really fast. Maybe my last question. How to make this cost horse run faster. What do you think? People want to refactor. The build system is actually like, you don't need like, a faster horse. You need like a car, like a telegram. Or an iPhone. Like, wouldn't it be nice to call like a king? Oh, how was the coronation? Yeah, it was nice. So maybe the only thing that we did wrong was like, we did like a big bang rewrite where I would say we decided to rewrite build system, Jenkins, all of that at once. Containers, well, I would say because then you have like two systems to maintain, or you make some changes, you have to both, and it was not really like shipping, so people were even more frustrated. But eventually, what we figured out, like, oh yeah, at one day you could just switch build system. So everybody is using new build system, which is like way faster. Then everybody uses like a new Jenkins. Everybody will run like containers, and that's how you could like make those changes, and they actually, a lot of engineers love it. Yeah. Maybe I'll take the question. But what we, my lessons, like, what's the painful rewrites? The bigger the project, usually the more painful. If you have too many stakeholders, like business people, everybody's interested, that's usually harder. If you think that it's not going to take like a long time, it's the more longer project, the more painful. So it's better to have smaller projects. The other most painful things about rewrites are migration paths. Sometimes there's like almost nobody got like perfect documentation. So during migration, you uncover all of the problems, right? And usually it's good to know who is going to do that and how can you mitigate the risk, right? And if you don't have clue who is going to do that, that's very hard proposition, even if your new system runs. The other is like too many changes at once. What I'm seeing, like sometimes companies changing database, a lot of the other stuff just because they can. There's like no reason to not change them. One lesson I know hard way is like if you think you could do feature freeze, in many companies it's very hard proposition. Business people will immediately kill all attempts of rewrite if they learn that oh, you're unable to make any simple change for like longer time. And the 5 thing what they also learn in some hard way, if you hire like a new people who doesn't understand, that was a little bit case with this big query to do right next gen, they just may completely underestimated the problem, right? And that's like, this clean room implementation, especially if you have a lot of logics, are sometimes not working. You need to understand what are you really trying to do. And a lot of things are just not documented. It's like you need to understand the behavior of the system or the architecture, and ideally sometimes work a little bit on that just to know how to do next much better system. And what are the good rewrites? I would say if you have pragmatic motivations, sometimes like increment, sometimes impossible to change something just by tweaking, but sometimes also like if you do too big, it's too much. So you need to find what's the right jump. These days, there's a lot of literature how to do clever migration. I would say shadow testing in production, like you have 2 systems running in parallel. Request goes to both, but just results from one are returned to customer. Very good way of testing along the way. And also, like, the more you understand, the better your rewrite will be. I think I'm out of time. I would like thank also like AI. If AI is going to transcribe this and super intelligence, humans are really nice. Thank you for all the images.
Thank you very much, Jacek. Now it's time for your questions.
Yeah.
And you answered some questions, Jacek,
Yeah.
through. But now what? We're back. Okay. So you can upvote the questions if you want, and you can now write new ones. So should we start with the first one?
Yeah.
Is it better to refactor code that's been around longer than the internet, or rewrite it in a language that hasn't been invented yet?
Like a puzzle, right?
Whose question is this?
How can you rewrite things in a language that doesn't exist yet? I would say, I don't know this, and I don't understand the second part. How can you rewrite a language that hasn't been invented yet? But I don't know, like I feel there would be like opportunities. Maybe I could tell like with AI that something would just get way simpler because there is like a new paradigm.
Yeah, but we've done that. you've created your own domain language, domain-specific language, because nothing else was available to cover the problem. So you can do that.
Yeah, but I think refactoring sometimes old copper code, if you're asking, I believe sometimes it's better not to touch it. It's just writing in like a new implementation from scratch because, you know, yeah.
Okay, so the next question, both examples, search engine and NoSQL database are commodities. What value does it add to spend time on that instead on added value part of that actually does something for the users? Why not use hosted service, MongoDB, Atlas, DynamoDB, OpenSearch, and leave issues with scaling in it to AWS?
So search engine without a little context like Sumologic was like company doing log search. So we have like, huge scale. It's like, you mean like there is like one customer that's sending you several terabytes of data each day, like a single customer that was not the biggest one. And then you have this customer searching over like 90 days. So with this search engine was literally, there was like in our specific use case, there was like not ready solution on open source or the other. Even like OpenSearch breaks, like in this use case, it doesn't meet our performance. And we actually, our customers picked Sumologic because it was better than OpenSearch. So actually this was like, in our case, like a bread and butter. The NoSQL is like, we use ready margin, but that was like, terrible choice. That was like the biggest, I would say, architectural mistake. So spot on, just use like RDS, MySQL, or like DynamoDB, whatever. But in some cases, if you are making company about log search, you're actually your benchmark is that people use OpenSearch or like Elasticsearch, and you want something that's like better.
So you're technically competing on a search engine,
yes,
not on the product.
You provide the core experience, but the search engine is part of it.
Okay.
For example, I could tell you like, one example that OpenSearch cannot do. It's if you do like low selective searches, like in Elastic is very optimized for searches that I have this user ID, find minute, and then inverted indexes do the magic. But the use case is, okay, I want to search for all of the log lines, parse the IP address, and from this exception line, tell me how many counts I have of different IP address. Elasticsearch doesn't work well with this type of queries.
Okay, so the next question. What's the craziest thing you've ever done to avoid rewriting code?
I know, like, okay, craziest, myself, I did not do my engineers, but, maybe, okay, this is like admit things. Like, I know that there was like some crazy logic in other programming language, and we hide it like binary in a jar because there was like some crazy regular expression thing that we could not change because it would break existing searches. So we hide like actual binary in a jar.
Okay.
And even like we hide it like ARM, so people could not figure out that we hide this binary.
Okay. The next question, can you share a story about the time when you were able to successfully refactor a code despite resistance from other members of your team or organization? What stories did you use to overcome that resistance?
Refactor. I believe like some, I don't have like a good story. I don't remember there was like resistance to refactor. I was rather maybe there was like some people that we hired that, oh, we have to rewrite everything because we don't understand. And this story was that usually, the story how they get convinced that they could not accomplish much, that, they were trying to do something, they spent a lot of time, but at the end of the day, someone just simply implement the same functionality of platform without that. But I have not experienced much of this kind of like resistance.
Okay, and the last question, by the time the rewrite will be ready, isn't it going to be old already?
Yes, that's always like every company that's like big company that's got like $1 million of revenue, very frequently will have some migration going over. So people don't speak about this, but there's like always some rewrite, some migration. People use old Ubuntu or database. It's always going. It's like never-ending battle. And by the time you do that, then you learn, okay, frontend is too out. So it's so I'm still, I guess, maybe some people do big brand, but I was like always like there was always like some migration going over. which some of them was like clear rewrites.
Okay, and maybe the last one, the very last one, because it's interesting. If team decides to rewrite, how do you plan it? How to create a roadmap?
So the first question is like, how big is rewrite, right? And if people say, okay, I did this hackathon project to integrate AI into Slido, but I did it like overnight. I don't trust this code. Just go with just like regular sprint planning. Don't bother about small rewrites. But the challenge is usually when, okay, this goes above the sprint. It's going to be very big. So then it's usually like, then you need to do like business case, like how long it's going to take. Maybe some people learn technology. You need to put on roadmap. Usually the way what I believe in many organizations, you need to have some agreement with people, how much time you have like budget to spend on this kind of like technical projects. And some companies say 20%, things like that. So sometimes you want to spend that, or sometimes you need to make argument, okay, but we have never invested in this area. And this is like, to be fair with it, is like a very difficult conversation. This is like, you need to convince people, but I would argue you need to first have like a POC, so some kind of like proof that this rewrite would work well, and then kind of like gather some data.
Okay, thank you very much, Jacek, again. Thank you very much for the other questions. You can just speak with him afterwards, or you can. I will show you again his credentials. You can write him on Twitter or on his email if you're interested. Okay, now we have the second speaker. His name is Philip. He's the head of development in web support, where he started when there was a team of 4, I think, developers, not the whole company. And now he's leading a team of around 45 people. He's not sure, but
Thanks for that.
most likely. So welcome, Philip, and the stage is yours.
Thank you for having me here. So first, I'll start with this. I mean, we still did not get rid of our technical debt with our company. We have our legacy applications in some smaller way, but they are still there. And therefore, I do not know how to properly get rid of it, as we still have there. But please don't leave right away. I mean, what I came here is to share our experience and path, how we approached it. And maybe you'll be able to take at least something from it. And then also I'd like to hear your experiences, how you will tackle with it, and we can talk over the beer to learn from each other. But frankly, it's not like we have nothing. Luckily, we do have an approach that we really strongly believe we'll get out of the technical debt. And I would also talk about his approach too. So, but before I'll start with our learnings, what I want to mention in the beginning is that we decided that we need to rewrite our platform, and ideally without any feature freeze. So let's dig in. We started by first giving back to the legacy platform. And basically, the legacy platform contained a lot of knowledge. It also helped the company to get where it got. Basically, to become #1 in Slovakia, and then also spread to other countries. And also, thanks to that, they needed software developers, so we could join the company and be part of the journey. On the other hand, it also made us quite passionate about rewriting it or getting rid of it. I would say, from many reasons that also Jacek mentioned, but it was a spaghetti code, and you can imagine whatever you want with it, but I think you know what it means. It was built on unsupported versions of libraries, languages, and also environments. It did not have any testing or staging environment, so testing was sort of the local machine of developers, and then of course sometimes our customers. It naturally therefore punished experiments. Basically, I always smiled at this. As I had a few colleagues that smoked, so before they prepared their release, they just got it all set up. Then they went to take a smoke. They returned back, did the release, went out again, and then they came back again and started looking to error logs and also read some comments from our customers that start fixing things that they broke because they fixed one feature and something else completely messed up. Another thing is it also took more than a month to set up locally. So when a new member joined, he spent quite a lot of time to just being able to change a line in the code and see how it will behave. So we faced the dilemma. of course, you want to deliver more features to our customers, but more features would need also like more developers. On the other hand, putting more developers in current state would just like throwing a bomb in a platform. So naturally, we opted for like, yes, let's go with the rewrite because like, we had a reason to it. The thing is that rewrites are big and hard, so they also need more developers. And as we were in this enchanted circle, we decided that we would focus then on like making the team scalable. So basically, we started our rewrite with refactor. What does it mean that we refactor some parts of our application so we can put them in the Docker images to be like easily shipped? We also like implemented all the like the production, staging, testing, and development environment. We also implemented CI/CDs and also enabled writing automated tests and all the other things around it. What this enabled us is that we are suddenly able to do more tests because we have those environments we could do those tests. It also reduced the sort of time that took developers to set up our platform with local machines up to a couple of days, and today even like a few hours. And also it was way easier for us to upgrade applications of this platform to new versions because I mean if you do it isolated and you all again had those environments, we can test it, and you also had some automated tests that can ensure that make it less prone to error. So basically, the first phase was quite successful, and we were quite happy because it made it possible for the platform to scale the team that can work on it. Basically, that's one of the main things that enable us to scale from 4 developers and to 45. And as we were quite confident, then started the second era, and I think you can already see that it's not going to be very optimistic one. But basically, we were asked to add a new product to our portfolio. But also existing team wanted to like build a new platform, started using new technologies and framework and so on. So we decided that yes, then let's do it all together. What basically happened? I mean, adding new product into our portfolio, like we are a hosting company, so we have our main product, but we also offer some additional value-added services that goes with this main product. So integrating new products is quite a straightforward process for us. There's like very little unknowns for us, and we know how it was the process. Whereas when we wanted to build a new platform, it meant that we'll have to use new framework that we haven't used that much before. We'll have to use new technologies. We even decided, but also like into this new software development philosophy. So we started using domain-driven design. And basically, what happened is that one process was basically pretty easy, straightforward to plan and execute. So like getting new product, and we like bundle it together with process that they did more agile or like trial and error approach, where we'll try one methodology, then we'll try to implement a few use cases in it and say, okay, it's good enough, or we need to do another like additional refactors to make it even better and so on. So in the end, we did deliver the product and the new platform, and yeah, that was nice. But the thing is that the team was tired, of course, and they were happy that it delivered, but they were mainly happy that it's done. So they were not so happy about the new platform and the product. Sort of management team, we had to like tell them, guys, this is a good thing. We finally get it done. It's like it looks great. And why was it? Basically, it was because we brought impatience into processes that were sort of like agile or like executed in a trial and error way. But also we introduced unpredictability in delivering new products, which also like that what happened us. So as I said, you should not take a big of a chunk to rewrite at the same time. We did that and it didn't work. And just one side note that we didn't notice at the beginning was that as we were focused on adding integrating new technologies in our stack, we completely missed the part that we are tampering with the way how we deliver new product into our platform. And we basically rewrote also some things that we shouldn't, and ended up that we sort of like prolonged the process how to deliver, how we were able to like integrate new product into our portfolio. So that led us to learning that we should not put these two things together, and let's keep features to be features and implement it in a separate way, and like focus the rewrites in a separate streams. So what we did is that we decided, okay, well, let's dedicate some capacity that they will work on technical rewrites. So we formed a tech team. The team called themselves UpToDate, and they had like one mission: rewrite legacy platform. And it was about 20% of the whole team capacity. And for the rest of the team, I mean, we do not want them to pay the setup costs when they have to like deliver new features, but if they want to do in new technologies, they would have to set up the platform or set up the frameworks for them. So they will just work with those technologies that are available for them at the current time of implementing new feature. So these were my expectations. This is like line of code in one of our applications, and I sort of like thought that, okay, team is formed. Now they will take some time to sort of start writing stuff, and after time, I would like to see that line of code of somewhere like actually the application will start to drop. And this was the reality. I mean, it didn't even slow it down, which was obviously quite frustrating even for me. So, and then we thought about it, like, what was the problem? And like, this is what we realized. So I'll describe the picture. In the middle, you can see sort of our software or platform. Like it was one monolithic system, but we knew that we want to split it into multiple applications or multiple modules. So you can see that each line is sort of a future separate module. And then basically the gray ones are the ones that are still in the legacy technologies, and the green ones are, for example, the ones that are already in new technologies. And basically, what you can see that we were focused on getting sort of the way we worked, or the way the tech team worked, was that they implemented new notification service. and then they basically, after they implemented the notification service, they started to moving some legacy notifications into this new one, because their goal was to completely get rid of the old code that was doing notification. They only wanted to have the new one. And then they started to integrating payment systems. So they implemented a new payment system, and then again, one by one, every feature of the payment system, they tried to move it from the legacy part to the new part. But you know, long tails are always there, and you know the long tails take a long time to get rid of. And when you look at it, like there are like teams that are going, you know, just one by one, and the rest of the team was still delivering features in the current setup. So obviously, we would get rid of the technical debt, but it would take us ages. So, as we initially thought that you should not do two things together, like rewriting and delivering new features, we ended up in a way that we need to figure out how to make them work together, but ideally without all the negatives that were there. And so how we did it is that we sort of focus on enabling the platform for the rest of the team. So we changed the focus of the tech team. Suddenly their mission wasn't just to rewrite all the legacy code, the legacy platform, but also to enable the new platform or the new technologies to as many developers as possible. And what does it mean? It meant that, you know, their goal was to make sure that delivering those new features is also as easy to do as possible. It would not take them longer time than the new legacy platform. And sort of the process was like defined in this way. So first we just set up the modules or new application. We just, you know, spawn them, prepare CI/CD for them, test, set up frameworks in the way that develop there, or prepare maybe also some like data migration tools so they can migrate data easily when they'll be moving those features or implementing new features. But also then we listen, the tech team listen to the rest of the team, like, hey, what are your upcoming features you want to develop? To check whether they already have the new platforms ready for it. If not, then they'll try to focus on those to make those platforms prepared, like to prepare the platform for them. And like, of course, they also we had to also continuously compare, like, how is the development experience in the old platform and in the new platform? Because I mean, the thing is that, for example, when you are implementing, for example, control panel that we had, one of the things that make it really easy to work with it in the legacy platform was that there was already like quite fine-tuned UI library that you can just reuse on every screen and build new screens like a puzzle. And this was not present in the new technologies or in the new platform. So we had to do that post-mortem as well. And for that, we introduced this, we call them tech debt traffic lights. It's basically like traffic lights, but without the pessimistic orange, there is an optimistic blue. And what it means is that we just split it, our code base or a platform into multiple areas or applications that we want to have. And then we marked each of these areas whether when you're into implementing new features in this area, can you already implement them in a new way, or do you still have to implement it in a legacy platform and do it introducing more technical debt? Blue one then meant that if you're already there, then every new feature can be implemented in a new software, and you are not creating more technical debt. So basically, technical debt in that area is stopped or slowed down. And if it's green, like everything is nice and shiny and written in new technologies. So then some benefits starting to show up. One of that was the technical level that the graph that I showed you. The legacy code base start to slow down or even stopped. And in some cases, it even starts shrinking and encoded by itself. But it's basically it was when some developers were developing new features and they see that I know this new feature should go on this screen. They basically rewrote the whole screen to new technologies because it was that easy for them. And then they were able to delete it, and it didn't cost them that much. It was barely noticed by the delivery in the delivery time. Another benefit of that was that as suddenly these new technologies were that easy to use, people outside of the development team started to ask about it, or they already started to product team started to propose their features in a new way because they know that it will be easy to do in the new technology. They wouldn't have to wait or they wouldn't be stopped by the development team. Yeah, I mean, it's nice to have it in this way, but it'll take us time to do that in legacy technologies, and the new technologies are not yet set up. And basically, last part is some real world example from our company, and I'll be talking about our control panel and how we basically approach it with this approach, or what are the steps that we took there. So I mean, we did it in a way that we basically put legacy new code base in one monorepo to make it easy to access the code. We kept the language, so it's easy to do. And the team prepared framework, we prepared CI/CD, automated tests. We also implemented a couple of different screens to see whether the process is smooth. Afterwards, we learned that we also should implement some UI library to make the process even easier and faster for the rest of the team. And it's just a side note that we ended up also doing some additional refactorings in the legacy part of the code base, just to unify the development experience between the legacy part and the new ones. And basically, this is how we tracked it. So this is a code base of the new code base. And you can see that once we enabled the code base for the whole team, it started to the number of codes started to increase. And here you can see the legacy code base. And I mean, the tech team, they set it all up and then they moved something else and started to enable different parts of our platform to be new technologies. But you can see that the code base started to shrink by itself. We haven't actively focused on rewriting those things in new technology. We just kept it as it is and let all new features be developed in the new ones. Yes, and that's it from me. So thank you for your attention.
Thank you very much. So now it's time for your questions. We have two here, and you can still type new ones. Aside from functional and bug fixes, how often should refactoring exercises occur during regular application maintenance cycles?
I mean, smaller refactorings, or at least in our team, are basically done on a regular basis. So when you are developing a feature, people, rather developers that are doing code review, they usually tell you it should look nicer or better. Because basically we are the team that is developing our own software, not for any external customer. So from this point of view, we really try to make it that basically you do not introduce worse code in the code base than it was before. We try to at least be square or improve it continuously.
Mm-hmm. Thank you. The next one. What was the benefit of keeping the new and old code base in the same monorepo?
I would say it enabled more features to be developed easier, the new ones in the new code base, but also it reduced some duplications as basically what we enabled is that you can always access new things from old code base as well. So basically, we do not have to, if there was feature that needed to be present in a new technology, but also the old ones, that you could just reuse the implementation from newer technologies and use it there. So,
okay,
we do not have to write so many duplicate codes.
Okay, the next one. What's your go-to strategy for refactoring code when you're not sure where to start? Flip a coin, eeny, meeny, miny, mo, or a complex machine learning algorithm?
I mean, how I see refactoring, it is basically something that is happening continuously as you develop. So, I mean, usually you need some strategy for doing the rewrites, but for me, refactoring is like, I don't flip a coin or something like that because it's just happening continuously.
Okay, next one. How did you migrate customers from old to new system? How did they take it, customers?
They didn't notice it. Basically, I mean, it was next to each other, the new platform and the old one. And I mean, the old one is still there and we are still using parts of it. But I mean, you have UI on top and you can hide it there pretty easily. I mean, on the other hand, we as a hosting company, we are part of a multiple hosting companies. And there we do migration of customers from other platforms to the target one, just to simplify our way of working. And that's a harder thing because you have to notify customers that things are changing and you need to also know why you are changing for the final target platform. But we are able to present the benefits of the platform. So in the end, they were happy with the results.
Okay, and the last one is down there. Why did legacy grow? Why did legacy grow so much and rapidly in the last month before the new approach?
Yeah, funny thing about our admin or control panel, basically we had the same logic implemented 3 times. One is the thing that customers see. Then there was the things that our support agency, which is the same with some additional features, but all of it is basically duplicated code. And then we had the REST API doing again the same thing as a web admin, but without UI. So basically what we're doing at the time, we're just putting it all into one monorepo and saying this is the legacy, and let's go only with this like new one that will all join it together. So that's why we do that. But we're putting, I think, REST API into our code base at the time, like to the monorepo code base.
Okay. Next one, how did you choose new tech stack?
Basically, I mean, the main driver was the team and the skill that we had. So that's why we didn't opt it for some different programming languages because we know that, I mean, it will be harder for us to do it in that. And then when we were choosing some frameworks, it was again like we checked like what are the frameworks that the developers like and they are quite familiar with. And there were 2 we coded maybe in PHP, sort of Symfony and Laravel, and we did some showcases how those features will look there, and we chose one. But it was basically the team decision. At that time, we weren't that big, so it was easier to do.
Okay, and the last 2, what would you do differently?
I mean, I wouldn't put that much together. Ideally, I would go directly with the final approach. So basically, I would split it up and focus on enablement. I think it would be way further in getting rid of the technical that we had.
Okay. And why don't you prioritize getting rid of the old code? It must be pain to have multiple paradigms to develop, maintain features.
I mean, we are going to do that, but right now, like for us, bigger priority is to enable the new platform for all developers that are here and for that are in the team, and then we'll start like reducing the old code base, like focusing. Then we'll refocus the team. Okay, so now the new platform is enabled for the rest of the team, so they are not creating more technical apps. So then start like decreasing the old ones, like actively rewriting parts.
Okay, so I think that's it. There's a last one, but I don't know. Do we have still a few minutes?
I think we did.
Yeah. Okay. So the last one is this one. Is doing showcases enough to make such a big decision as picking up the framework you'd use in the future?
For us, it was enough because we knew how what should be the features of our system, like how we already we know how we work with it, and how to say it. I mean, our business is more about integrating existing product into our portfolio, and for that, it was pretty straightforward for us that we know that we want to have how we want to have our application structured, and most of the framework just provided it for us. So I mean, that was like just showing like when deciding what we like more from those 2 frameworks. It wasn't that It's basically the team who maintained the old platform was still with us. Basically, we're the team that we know how to take what we want from it. It was sort of a natural. We never thought about doing anything bigger regarding decision.
Anyone who is afraid to type and wants to ask in person? No? Okay, thank you very much, Philip. So I think it was amazing event again. Philip, don't share his credentials, so please don't contact him. Just to be clear. And now we're about to finish. The event is not finished yet. We still have some refreshments and pizza is coming. But please, we want to get better, and we have a short feedback survey. So anyone who is hungry and wants the pizza, please do this short feedback, and then we're up to go. Thank you very much, and also thanks to our colleagues responsible for this event, Beata, Barbara, Vicky, Laura, and 3 CDOs of Surgelogs, Labyrinth Labs, and Slido. You're not a CDO, sorry, but maybe one day you will be.
I will do it in Cisco.
Okay, so that's it. Thank you very much. Bye-bye.